Okay, today we're going to build on what we did yesterday. So we're going to do the mean absolute deviation, and then we're going to do the standard deviation, and we're going to look at the difference between these two. So first we have to get our average. So we have our there we go. So say, okay, let's do the average here. And so we do first our average for this set of values, okay, where the difference is always 2, either 2 above or 2 below. Then we're going to do our difference. Where we vary from 1 below, 3 below, 1 above, 3 above. Okay. And what we saw is that when we do the absolute value, so we say, okay, let's do the absolute value. And we want to, remember, use the $sign B, $1. And say we always want to use exactly that average. And the difference between that and the cell to the left of us is 2. And then we pull that down and we say, okay, everyone's 2, that's what we expect. And then for the data in which there was more variety, right, it still averaged out to being 2 different. Do the same thing, so we say equals, remember you need the equal sign, absolute value, and then this difference, so even though they're the same, we're going to be careful and say, we do $sign B, $10 minus A11, and so we get 3, and then we pull our formula down, and we get that difference. Okay. And so remember, what did we get for the mean absolute difference of these? And so let's make an extra column at the top. So we make 2 more columns at the top, and so 2 above. So, okay, so we do set 1, mean absolute deviation, and then set 2, equals. Okay, so all we had to do for that is take the average. So that was the average of all the differences. And then of the second set, it was the same thing. We said we'll take the average of all the differences. It was the average of all the differences. So we went down there and we said, ended up also being 2. Now, here comes the difference here, is that what we're going to do is, so if we look at the formula, we found the mean. Now we're going to find the square of its distance to the mean. So we do the first step that we did for mean absolute deviation, but now we're going to square it. Okay? And a lazy person's way to square it is just to say, for example, equals B4 times B4. I'm just going to do this number twice. So we get 4. And let's pull that one down. So we say, oh, everything's 4. Now, let's go down to the second set. We're going to do the same thing. We're going to say equals B13 times B13. Okay? 9. Okay, that's what we expect, right? So we say 9. All right. So now you begin to see the difference. Okay. So before when we had all 2s, we had all 4s. When we have different data, look at how the 3 has a much bigger impact than the 1. 9 versus 1. Okay. All right. So now what we have to do is we have to take the average. So if they show it here in 2 steps, add everything up, and then divide by the number of data points. So steps 3 and 4 we can do easily, though. We can just do average of squares of difference. Okay, so let's make this column a little bigger. Average of squares of difference. And let's have this guy come around. So the average of the squares of the differences. Right? And so the average here is going to equal. It's going to equal the average of that. So we're going to take the average of the 4s, and you get what you expect, right? Which is 4. And make this guy a little bigger. And then how about this guy? So he's going to equal the average of these guys. Now, yeah, so is that going to be 4? No, it's not, right? So it's going to equal 5. So we got a difference. So okay, let's make it 14. Make it even a little bit bigger. Okay. So, well, is our average deviation 4 or 5? No, it's not. There's a last step. So we divide. Now we take the square root. So we say equals the square root of the thing here. And that would be the square root of C3 is 2. So we see that when all the values are the same, right, there's no difference between the standard deviation of 2 and the standard deviation of 2. And then over here, what happened though? We say equals the square root. We take the square root of C12. And we get 2.2. Alright. And so the thing we're trying to see is, well, why is it different? Why did we get a different value? And the reason is, right, the reason is that if you have 2, 2, 2, 2, when you square them, you get 4. Take the average is 4. Take the square root, you get back to 2. But notice what happened when you do 3 and 1. You square 3 and get 9, square 1 and get 1. And so the total amount of difference of the squares is 10 versus 4 plus 4, 8, right? 9 plus 1 is 10. 4 plus 4 is 8. In other words, in the language people use is weight. You're giving more importance to things that are further away. So by taking the square, the 3 is given more importance, right? If everything's 2 away, you say, okay, I square them, I get 4 and 4. If you have 3 away and 1 away, in mean average deviation, it doesn't matter, right? It's just, okay, average is 2 away. But here we say, I want the ones that are a little further apart to count more. So I square it, and then take the average and take the square root. So that's the difference. We'll be working on it some more in distributions. But this is enough for you on the release test to know what to do. And on that one, it's a very similar example, where you're going to get a different result, because if you have differences, the ones that have get accentuated.